This clip covers SAG calculation within Innova Engineering. So as an example, I'm going to go to File, Open, Example Projects that come with the install, and I'm going to go to SAG Example Project. With this open, this is a pre-populated engineering file that has all of the required inputs to run a SAG calculation. SAG is what occurs when a BHA bends under its own weight and when positioned between 2 points of stabilization. So the degree of bending is affected by the hole size, stabilizer size, the distance between the points of stabilization, and the tubular OD and ID, i.e. the stiffness. And this SAG causes MWD sensor misalignment in relation to the borehole, so it's not always perfectly centralized. And this SAG can account for up to 80% of wellbore TVD position uncertainty. So that's what SAG is, and because of that positional uncertainty it brings in, that's why we correct for it. So the first thing we need to look at in our ING file is the units. Make sure we've got the units set up correctly, because they create the building blocks for the rest of the ING file. Next we've got options. So we've got SAG calculation precision, which gives the number of decimal places, and also we've got include motor bend in BHA analysis. So it's up to company policy, but in this case I'm going to select no. So the things that we need to input for running a SAG calculation are the drill string. So we've got the drill string and lengths, and within that drill string specifically we need to input any stabilizer dimensions. So these three measurements specifically: the stabilizer OD, stabilizer blade length, this is the contact area with the wellbore wall only, and the stabilizer distance from the bottom, i.e. the pin to the stabilizer base measurement. And that is the case for all of the stabilizers. The other critical thing is the OD and ID, and that dictates the stiffness of the assembly as well as the length. Next we need to fill in the wellbore geometry. This gives the ID of the wellbore that we're in, so that we know how much space this BHA is fitted within, and that will dictate how much the BHA is bending. We also need to input the mud weight. The mud weight obviously affects buoyancy and how that BHA sits within the wellbore. Next we move on to surveys. So a SAG calculation can be run with either actual surveys, well-planned surveys, or raw surveys. It doesn't matter which, you can run it on all of them. I'm going to do it with raw surveys just for the purposes of this example. This dialog here, this surveys correction, is where we need to input our data for the SAG calculation. We need a survey offset. That tells us where our survey sensor is within the BHA, so that the software can highlight how much SAG correction is applicable at that specific point. Next, we select the calculation type, so we can calculate it versus a single user-defined survey, so with a dogleg severity and inclination and a tool face. We can select it over an inclination range, so from 0 to 90 degrees, for example, with an inclination step of 1 and dogleg severity of 3. Or we can select surveys, and this will calculate SAG correction for all the surveys that we've currently got selected, whether that be in the raw surveys, which we've currently got opened, or well plan, which we've currently got. So depending on what survey table we have open at the time, when you calculate the SAG correction, that will be the one that is used when surveys is selected as calculation type. So now that I've input my drill string, my wellbore geometry, my fluid weight, and my surveys, I'm now going to go calculate BHA analysis and SAG correction. Okay, so this is the output that is created once the calculation is completed, the BHA analysis and SAG results dialog. Within this, we look at the MD, which relates to our original surveys, the original inclination for that survey point, and the corrected inclination, as well as the SAG correction applied. What we have above this are the BHA deflected shape and the BHA slope. So what we can see here, based upon our BHA, is that beyond about 190 feet, the BHA is sat on the low side of the hole consistently because there's no stabilization. But between these points of stabilization, we have a deflected shape, and we also have a sloping. And it's this sloping that gives us our SAG correction. The other items involved here, the bit side force, build-up rate, walk rate, and critical RPMs, they're related to the BHA analysis, which will be discussed in another video clip. Now that we've run our SAG calculation, if we go back to the raw survey dialog, we can now see that we have an inclination SAG populated and a delta inc. And this is being created after running our calculate BHA analysis and SAG correction. These have been pulled in. So now we can either select to have our original raw inclinations in our survey record, or whether to use the SAG corrected inclination. A very important point to note is that company policy may dictate that you don't run SAG calculation on any surveys in the range of 0 to 3 degrees inclination. And that is because there is not a defined high side to the hole when inclinations are in this low range, and so SAG calculation should not be applied. Anything above that 3 degrees inclination, depending on company policy, is applicable for running SAG calculation on. That completes the introduction to SAG calculation within Innova Engineering.